Our Cisco iOS devices are going to have many different storage locations, and understanding what goes in the different storage locations will help you in the long run. So first of all, we have what is known as NVRAM, non-volatile RAM. What does that mean? Well, RAM refers to random access memory. It's a type of memory, but non-volatile is referring to the fact that this type of memory does not lose the information that's stored in it if electricity, power to the device is lost. So what is a valuable piece of information that we can store in NVRAM? It's our startup configuration file. The startup configuration file is going to be loaded when the iOS and the device boots. So here's what happens. You have a router or a switch, it boots up, the operating system is loaded, and then what happens after that? A configuration file is looked for. Where is one of the places we can store the configuration file? In NVRAM. Now, if there's no configuration file, then default settings are loaded by the device. But if there is a configuration file stored in NVRAM, then that is what's loaded. So what we have is we have what is known as a startup configuration file that's stored in NVRAM, and we would create that ourselves by simply copying our running configuration to the startup configuration, ensuring that if our device ever reloads due to a power failure or a forced reload due to maintenance reasons, then the configuration that we had before the reload or the failure has been stored and backed up in the startup configuration. So think of the startup configuration as a local backup of your running configuration. That's what it is. It's a local backup. Is that necessarily a good thing? Well, it is a great thing, but you'll also want to store a copy of that on a remote device, like a TFTP server or an FTP server or some server in your organization, so that way there you have a backup of the startup config in case what? The device completely blows up on you. If it completely blows up on you, well, you need a configuration file to return to during your disaster recovery procedures. So RAM now, random access memory, what's that all about? Well, random access memory is volatile. So if we do lose power, everything in RAM goes bye-bye. But this is a great place for the running configuration to be. And what is the running configuration? It's the current running process, all the commands, the configuration, the operating system, everything is happening in RAM. Everything's happening in RAM. So the running configuration is in there. It's what is happening right now. Anytime I execute a command, hit enter, that's happening in RAM. That's not happening in NVRAM, it's happening in RAM. Which means that I'm going to have to, at regular occasions, every time there is a change made to our device, copy the running configuration to the startup configuration. By doing so, I have just made a backup of the contents in RAM, the running configuration, to the startup configuration, which is in NVRAM. Now, flash memory is another storage location. Flash memory is definitely a non-volatile type of memory. So if we lose power, no big deal. Nothing's going to go away in flash. It's going to be there forever unless it gets corrupted. What do we have in flash memory? Well, this is where we're going to store our backup configurations, maybe backup software. It's where our iOS image is, so the actual software image is located in flash memory. Might also be where we have to store some additional software features or services that we expect our router or switch to perform. We'll load that or store it in flash memory, and it'll get loaded during the boot sequence. So that's what's going to happen in our flash memory. So the Cisco iOS software is stored in flash memory, but it doesn't run in flash memory. No, it runs in RAM. So what will happen is when the device boots, it'll load the operating system and put it into RAM. The startup configuration file will then be loaded and put into RAM as well, and that becomes the running configuration at the time of startup. So it's really important that we manage our configuration files appropriately. So that way there we have a backup of our configuration. So one of the things we're going to do is copy the running config to the startup config. So that command is going to be copy running config to startup config. But we'll also want to make backups of the configuration as well in case the router or the switch fails completely on us and we can't access the startup config to get the configuration file out of it. Well, then it'd be good to have that information on a TFTP server. So in this command here, we're typing copy from the running config to the TFTP server. We could have copied it from the startup config if we wanted to. Doesn't matter. It's just copy source. So the first value here is going to be the source, where it's coming from. And then the second value here is the destination, where it's going to. So copy from our running config to a TFTP server. And then in this example, it's asking us, what was the address or name of that particular TFTP server? Well, in this case, it's the IP address of 10.1.1.1. That's where we're copying it to. And then what's the destination file name that you're going to utilize in this case when it's being placed onto that TFTP server? Whatever you want to call it, you can call it at that point in time, or you can accept the default. So whatever's in brackets is the default. If you decide to change the name of it, you go ahead and change it as they did here, config.cfg. And how do I know it successfully transferred was this. If I see periods, that's no good. Periods are no good. It means the transfer was not successful. If I see exclamation marks, then the transfer was successful. And it would also tell me here that so many bytes were copied in so many seconds. So depending on whether you're using a reliable or unreliable protocol will help you identify if your backup was successful or not. TFTP is using UDP, so it's unreliable. So there's no way to know for sure just based on this whether it was successfully transferred perfectly or not. So if you see a lot of exclamation marks and a lot of periods during the transfer, I would be a little worried about UDP being able to successfully transfer all that information with TFTP. But if we were using a TCP, like FTP maybe, or HTTP for transfer, then we're using TCP. If I saw some exclamation marks and periods, well, based on the periods, the lost information, lost communication at that point in time, then TCP protocol would have retransmitted that information for me, where UDP doesn't. So if I see any periods at all when I'm using a UDP protocol like TFTP, I would definitely try to copy that over again until I get all exclamation marks. If not, then we might be a little worried about whether that's successfully transferred or not. So that's the difference, again, between a reliable form of communication and an unreliable form of communication. So TCP is reliable. If anything goes wrong, it'll fix itself. It'll retransmit the missing parts, where UDP doesn't do that. So always keep that in mind, that just because it looked like it was successful, if you're using a UDP protocol, doesn't mean it was 100% successful unless it was 100% successful for you.